Welcome to playing with sampling distributions for sample proportions. So the plan is we will be using an applet. Which will simulate drawing samples. Reese's Pieces from a candy machine. We will record the proportion of orange candies in the sample. And then we will look at the distribution of all of those sample proportions. So before we switch over to our applet, our first distribution distribution 1, we will be looking at samples of size 25, and we will be assuming that the proportion of orange candies in the actual candy machine itself is 0.5. So essentially, we're assuming a population proportion of 0.5, and then we're looking at what will happen to the samples. So let's go ahead and switch over to the applet. So here we have our probability of orange. That's the population proportion, the proportion of orange candies in the machine. We're looking at 25 candies. And then we'll go ahead and just draw one sample. So in this case, we had 11 out of 25 candies. And it put down here that that was a proportion of 0.44, and they put a dot for a dot plot. So now let's go ahead and just do a whole bunch more samples. So I'm going to draw a total of 500 of these samples, and we'll see what happens. So the very last of those samples was 12 out of 25, or 0.48 for a proportion. And we can see here that most of our samples seem to be between about 0.40 and 0.60 maybe for the sample proportions. but they ranged from 0.20 all the way up to 0.76. So I'm going to take a picture of this so that I can transfer it over. And then we'll go ahead and do the same thing again, but this time we're going to bump up to samples of size 100. So let's do this as a 1. And we'll go ahead and draw a sample. We seem to be having some difficulties here. Let me refresh this page. Let's do samples of size 50. And then I'm going to turn off the animation feature, and let's just go jump straight to drawing 500 of these samples. So in this case, oh, I forgot to show proportion. Oh no, it's there. Okay. So here we again have our proportion of orange. It again looks to be centered at 0.5, but our most common ones seem to fall sort of between 0.44 and 0.56 maybe. So we're at a slightly narrower interval. Take a picture of that. And then let's see what happens if we change to proportion of, let's say if 0.3 was, so 30% of the candies in the machine are orange, and we'll see what happens. So again, now we look to be centered more around 0.30, with most of our values falling between about 0.24 and 0.36 maybe. And we'll go ahead and take that picture. And now I'm going to add these into our notes and record the information we plugged in for each of these. All right. So again, distribution 1, we had our population proportion of 0.5, samples of size 25. And this was our distribution. So if we look at this, the center of our distribution is somewhere around 0.50. If we look for our sort of typical interval, I would say that our typical values are sort of between 0.54 and 0.60 is where most of the data falls. So our typical interval, I would say from 0.40 to 0.60. Our min to max interval, we are looking from 0.20 to 0.76. And the shape appears to essentially be normal. We have symmetric with a central peak. It's basically normal. Now we'll do the same thing for our next distribution. So for distribution 2, we had a population proportion of 0.5. This time we are looking at samples of size 50. Once again, our center appears to be around 0.5. Or 0.50. Our typical values are going from about here to I don't know, somewhere in here. So the typical interval appears to be going from somewhere around 0.44 to 0.56 or 58, we'll say. Our min to max, we're looking at, I believe, 0.30 to 0.68. And then our shape, again, our graph looks to be more or less normal. And then one more, the last one, we had a population proportion of 0.3 with a sample size of 50. Our center is around 0.30. Our typical interval is about 0.24 maybe to 0.36, somewhere in there. Our min to max, it looks like we have one around 0.10, 0.10, up to about 0.50. And once again, the shape appears to be normal. So for these, in all of these situations, it looks like our shape is more or less normal. The center in every case seemed to be just about exactly the same as the population proportion. And then our typical interval got narrower when we boosted up the sample size. So just some observations. All three shapes were more or less normal. All three centers were essentially the population proportion. And then the ones with a larger sample size had this narrower spread. Or a smaller spread. So in some ways, these make sense. Whatever the population proportion is, say if 50% of the candies are orange, then we would expect some of our samples to be right at that 50%. We would expect some of our samples to have under 50% and some to have over 50%, but it would make sense that it would sort of hover around 50%. If we have a larger sample size, that means that sort of the surprising things will be balanced out, or in the case of proportion, we just have sort of more chance to kind of get a representative sample if we're picking a larger sample. And so it's more likely that the proportions will be closer, so smaller spread. That's it for playing around with these distributions. In the next video, we'll do the official formulas.